Yes, friends, welcome back to Pure Math School. Today we are continuing the first topic, Algebra 1, and today we are proceeding to check into indices. So let us start off straight away. First showing what indices are actually, or an index of a number can also be referred to as the power to which the number is raised to, or the exponent of the number. Let me say that you have a number 2. Okay, so you have a number 2. The power to which this number is raised to is actually referred to as the number of times the number multiplies itself. So for this case, let's say we have only 2 like that. It looks like 2 is multiplying itself only once to give you 2. So for this case, we raise 2 to the power 1, which would be something like that. In case we have 2 multiplying itself twice, that means the power of 2 is going to be 2. Let me say that, let it be in this form, n to the power p, whereby n is the number called the base, and p is the power or the index or the exponent of n. So that's it. When we talk about indices, we mean the power or the index or the exponent of that number. Like for the case of 2, the power of 2 for this case is 1. Here the power of 2 for this case is 2. So that's basically it. So we can basically say that an expression of that form is given where this n becomes the base of the number, the base, and p becomes the power or the index or the exponent. Let us go into multiplication and division of indices. Multiplying and dividing indices. Now we are going to have different cases. For this case, let's consider a case of same base. That means base, I refer to this one, n. Same base but different powers, and we are considering multiplication. Let's consider case 1 to be, consider multiplying same base but different powers. And let us look at an example. Let's say we are having 3 to power 3 multiplying still 3 to power 2. Same base, 3, and our powers are 3 and 2. So now for this case, we're going to first simplify it in a layman way or very normal way. This simply means we have first 3 multiplying itself 3 times. So say the power or the index or the exponent of the number is actually the number of times the number multiplies itself. So for this case, 3 to power 3 means we're going to multiply 3 times for that first one. Then the second one means we're going to multiply 3 2 times that one. So now we can just count the number of times the whole of that or the number of times 3 is multiplying itself in total. So we have here 1 2 3 4 5. That means 3 is multiplying itself. What does it mean? We're going to have 3 raised to the power 5. Okay, we can check another one. Let me say 4 to the power 2 times 4 to the power 5. Okay, what does it mean here? We have 4 multiplying itself twice for this first one, and again 4 multiplying itself 5 times, so that we have something like 4 times 4, that's 2 times, 4 times then times another 4, that's now already 4 times, then times another 4, that's now 5 times. Okay, so the first one 2 times and the second one 5 times for here. Now we count the whole of that, 1 2 3 4 5 6 7. You realize 4 is multiplying itself 7 times. So that's how you do it. Now let's observe these two. If you observe these two, you realize that actually the power of the result of the multiplication of this of indices is actually just, you get the index of the result by just adding the powers of these individual numbers. You have 3 to power 3 times 3 to power 2. The result is 3 to power 5. Have you observed that? You can observe that 3 plus 2 gives 5. The same case here, 4 to power 2 times 4 to power 5. You observe that 2 and 5 have been added to give this 7. So in other words, we're going to conclude to give our first property of indices. Okay. Property 1. Okay, we realize that if you have a base to a power p and that same base to another power q, you're multiplying themselves, the result is actually that base, and the index of that result is just adding the powers according to what we saw before. Now let us go ahead to see multiplying a power by itself, let me say several times. For example, let me say consider multiplying a power by itself several times. Now an example we're going to look at here, we can have 3, let me say to the power 3, okay, multiplying itself, let me say twice. Okay, so that for that case we are seeing a base raised to a power and again raised to another power. In other words, this is the base of this, and this becomes the whole of this 3 to the power 3 becomes the base of that too. So we are going to, that means actually we're going to have 3 to power 3 multiplying itself twice. If we interpret that 3 to power 3, you say like just like a to power 2 is the same as a multiplying itself twice. Now the whole of that our 3 to power 3 is a. That's why 3 to power 3 is multiplying itself twice to give 3 to power 3 to power 2. Now the result here, in our normal way that we had been doing before, is 3 times 3 times 3 for the first one, then times 3 times 3 times 3 for the second one. What does it mean? We're going to have something like 1 2 3 4 5 6. So 3 is multiplying itself 6 times. Okay. Another one we can look at, maybe we have let me another example, 4 to power 2 then raised to power 5. That means we are 4 to power 2 is multiplying itself how many times? 5 times. Third one, we have the fourth, then we have the fifth. Okay, that means actually we have now 4 multiplying itself twice here for that first one. Here also 4 multiplying itself twice. Third one, 4 multiplying itself twice. Fourth one, 4 multiplying itself twice. Then fifth one, 4 multiplying itself twice. Then you count the total, you'll have 1 2 3 4 5 6 7 8 9 10. So you have 4 to power 10. Let us again observe this. You realize that you have the base. Okay, let me say base. You have a base a being raised to a power p. We are shifting that. Base a being raised to a power p, then raised to another power q. It's just the same as that base. The result of that is actually just having p times q. Okay, just like here, you had 4 raised to a power 2 and raised to a power 5. The result is just 4 to the power 2 times 5, which gives 10. So that becomes our property 2 of indices. Okay. Now we can check another one. Let me say under division. Let's say we look at we try to get to our next property. Let me say we are going to divide same the powers of same base but different powers. Okay. let us go to, let me say, consider dividing same base but different powers. Okay, so an example we can look at there, let's say we have 6 to the power 5 divided by 6 to the power 3. Okay, now usual way, this is the same as saying 6 to the power 5 over 6 to the power 3. Okay, then now what next, we can interpret that numerator is means 6 multiplying itself how many times? 5 times. Then the denominator implying 6 multiplying itself 3 times. Then 3 from up will cancel with this 3 down, will remain is only 6 times 6 in the numerator, which means 6 multiplying itself twice will actually become 6 to the power 2. Okay, if you have another one, let me say 4 to the power 3 divided by 4 to the power 1, this would simply mean 4 multiplying itself 3 times in the numerator, down 4 multiplying itself once, so that we have 1 will go with 1 there, so we remain with 4 times 4. Then we have 4 raising itself to power 2. Okay, now we can observe this one again. Let's observe the base. If you realize that we have a result 2, it will just be the same as the powers subtracting themselves. What does it mean? So for the case of division, the powers will actually just subtract themselves. We have a base, okay, say 6, raised to a power p, dividing the same base raised to another power q, which would represent that. This is just the same as having the same base but then subtracting the powers. That brings us to property 3 of indices. Okay, even here when you observe, you have that, for instance, if you see 4 to power 3 divided by 4 to power 1 is just the same as 4 to power 3 minus 1 to give us 2. So that's it. That's a third property we have. Now let's look at some special cases. Okay, the first special case we're going to look at is division when powers are equal but same base, and we try to see which other property we can have there. Equal power but same base. So now let's say dividing equal powers but same base. Okay, now we check out, let's say an example comes to be 6 to the power 3 divided by 6 to the power 3. As usual, we say this is the same as 6 to the power 3 divided by 6 to the power 3, which is the same as saying 6 times 6 times 6, so 6 times 6 times 6, which will cancel all throughout, remain with 1 out of 1. 1 divided by 1 becomes 1, right? So now we check on another, we see that is 1 actually, but now they see using our property of let me say our property of subtraction. Okay, remember we looked at before, when you're dividing same base different powers, just put that same base then subtract the powers to get a result. So that means we can also solve 6 to the power 3 divided by 6 to the power 3 as 6 to the power 3 minus 3. What does it imply? It's the same as 6 to the power 0. If 6 to the power 3 divided by 6 to the power 3 gives 6 to the power 0, here we also have 6 to the power 3 divided by 6 to the power 3 giving us 1. What does it imply? It means actually 6 to the power 0 is the same as 1. So here we can observe 6 to the power 0 equals to 1. What does it imply? We have a property here, a base raised to power 0 is 1. We can consider this to be our property 4 that we have come across. So if you have a base raised to power 0, just know it's 1. from this. We can see from this simple example that we looked at. Okay, let's look at another special case when we're dividing when the second power is higher than the first power. Okay, that's second special case, dividing when second power is higher than first power. Okay, now let's say let's check an example. Let's say 7 to power 3 divided by 7 to power 5. As usual way, first concepts, basic concepts, always very important. We just having 7 to power 3 divided by 7 to power 5. Okay, what does this imply? It means 7 times 7 times 7 3 times for the numerator, dividing 7 times 7 times 7 times 7 times 7 5 times for the denominator. And you realize that actually the 3 7s up will cancel with 3 7s down, remain with only 1 out of 7 times 7. What does it mean? It's going to be 1 out of 7 to power 2, since 7 is multiplying itself 2 times, right? Now, let's check into another way we can see when we use our normal way, the property. Which property was that? I think it was property the behind when we have when you have a base to a power, dividing the same base to another power is just the same as saying that same base, and you subtract the powers. Subtract. What does it mean? 7. Now 3 minus 5 is a negative 2. Since we have 7 to power 3 divided by 7 to power 5 giving us 1 out of 7 to power 2. And we have that same 7 to power 3 divided by 7 to power 5 giving us 7 to power negative 2. What does it imply? It implies these answers are actually the same. So we can conclude this implies 7 to power negative 2 is giving us 1 out of 7 to power 2. So what do we conclude here? We have a base raised to a negative power is just the same as having 1 out of a raised to the positive of that power. That is our property 5. Right? So we can check into another case. Now the third case of the special cases, we are going to have fractional powers. Fractional powers. This fractional power is going to show us how the roots come about when a power is raised to, when a base is raised to a certain fraction, you'll see it will result into roots. And now let's suppose we have our powers. Let us say we are considering same base. Let me say A, implying A, and A is to P, and Q is and another A is to Q. Okay, but P equals to Q and equal to half. We have that. So let us interpret that. It implies that we are going to have A to power half times A to power half. Okay. Now when we consider when we are multiplying same base, we add the powers, right? So we had half plus half. What does it bring? A to power 1, same as A. Now, when we interpret it this way, we have A to power half times A to power half. You see that A to power half is multiplying itself twice. What does it mean? A to power half squared, right? So what does it mean? If A times A to power half, A to power half times A to power half gives A. And the same A to power half times A to power half gives A to power half squared. Okay. What does it imply? Means actually the answers must be equal because they are coming from the same origin. Okay, so what does it mean here? Let's say that it implies that a to power half squared is the same as a. Okay, but now what if we get the root of this to remove that square? We get the root of that, we're going to have a to power half. That means taking root on both sides. You see that? We're going to have a to power half giving us root of a. What does it mean? We have a base, okay, raised to a power 1 out of p is the same as a under the root, getting the pth root of that number. You know that a to the power of is this a square root? Square root is represented like that, but in most cases for square roots 2 is left, but for higher ones 2 is always, the number is always put there. So we have that a to the power 1 out of p is the same as the pth root of a. We can call that property 6. Cool. Let's go to the last property, property 7. We try to look into it. When we generally have, what if now we have, okay, maybe before that we can check into, I think I concluded so fast with only one example. Let's try to check for cube root before we reach there. What if p equals to q equals to a third? We have a to power, that means, but for this case, remember we are looking for a way of making a to power 1. So that means we would multiply a to power third times another a to power third times another a to power third. Okay, that would mean a to power 1 out of 3 plus 1 out of 3 plus 1 out of 3 to give us a to power 1, which is the same as a. Okay, but also you know that the same 1 out of a to power 3 times a to power 1 out of 3 times a to power 1 out of 3 is the same as having a power 1 out of 3 cubed. Okay, meaning these two are equal since they are coming from the same origin. So we have a to power 1 out of 3 to power 3 giving us a. So when you get the cube root, you're going to have that. That means if you get the cube root of this result, we are going to have a to power 1 out of 3 being the cube root of a, which still goes back to our property 6. Okay, that's a brief summary. So for that, now when you go to higher powers, like for 1 out of 4, even 1 out of 5, you can do that by simply just, now 1 out of 4 means you're going to multiply the power, the base to the power 1 out of 4, you multiply that 4 times, because now you're looking to make the power of the result to be 1. Now let's look into the final case. Let me say to check our final property. Let us divide. How about if our numerator of the fraction power is of the power which is a fraction is not 1? Okay. Let's check. Consider when numerator of the power isn't 1. Okay, an example, let's say we have a to power 2 out of 3. Okay, now we are just using we're going to just use properties to help us see here. We already covered very many properties that we can just apply to here. You know that here we had a property that says this is the same as saying a to power 2 times a third. That can give us that, right? And you know that this is the same as it's the same as a to power third times 2. Okay, that takes us back to, I think you remember that that power, that one. There is a power when we had something like a to power p to power q, the same as having a to power p q. Okay, that's the same thing we are having here. We have this times and at times would just mean here for this one, and drop it down here, would mean a to power 2 to power a third. And this one, if we drop it from that concept, we are going to have a to power a third to power 2. Now we see that we have a squared to power 1 out of 3 equals to a to power 1 out of 3, then to the power of 2 again. So if we interpret this, we are going to see that we have, since it's a squared, we can have that. And you know that previously proved that a number raised to power 1 of the 3 is actually the cube root. Okay, and which is the same as this one. You already have the cube root starting first, so it's the cube root of a squared. Okay, so that's it. So what does it mean if you have a number, let's say a raised to the power p out of q? This is the same as saying a to power p times 1 out of q, which is also the same as if you manipulate that, we're going to have a to power 1 out of q times p. Okay, which will bring us to now this one becoming, this one here becoming a to power q to power 1 p to power 1 out of q. This one is going to be a to the power 1 out of q to the power p. Okay, and it's the same as saying that which is the same as, if you interpret this first one, it's the same as saying a to the power p under the cube root. Okay, which is the same as saying that here we have, if you interpret this one, we're going to have the cube root of a, okay, raised to the power p. So that can be our property 7. You can just manipulate and have those ones like that, and that's enough for the we have looked into almost all the properties of indices. And in our next video, we're going to talk about, we are going to look into some examples that will help us apply these properties that we have looked at today. And please, if you're new to the channel, please subscribe for more videos, and always say something, or comment, like, and also share the video if you have anyone you'd recommend the video to. Please, thank you. See you in my next video.